In this video, I'm going to cover an important topic that you need to know in order to successfully be a 3D modeler, and that is UV unwrapping. I'll show a little bit of the tools in this video, but this is mostly going to be an informative video where we discuss the theory behind it and what's going on. And one of the larger topics we are going to talk about is texal density. So what is unwrapping or UV mapping or UV maps, or you might have heard these terms in other classes. In fact, I know in the previous class you did texture objects on their UVs in Substance Painter. So now you're going to learn how to take your 3D models and prepare them to go into Substance Painter, because by default it would not be very pretty to pull what you've been working on into Painter and try to texture them. So what is a UV unwrap? I found a great image on the internet that kind of helps really illustrate this. And what it is that all of your vertices, all of your faces, have obviously their XYZ information on them, where each vertex has a position in XYZ space in your viewport. It also holds UV information, which is its position on a square image that we can then put on the surface. So kind of think of it as reverse putting together a box. Like if you think of like a cardboard box, how you'd fold it together. This illustrates it well of there is this image on the surface of this cube. And if we kind of grab all of those faces and unfold them onto a flat surface, this would be what would be in the UV space. So I do have an example to show you, just a very simple cube. And if we open up the UV editor by going to UV editor, and I pull it on over, this is what we get. So you can see how those lines look very similar. If we go back to here, to this, it's a slightly different shape, but that's okay. If we select the faces, we can see how they correlate to the areas in our 3D model. Let me just shrink this up a little bit so we'll be able to see both at the same time. Let's move this over. So if I hover over, we can see that this face here has the UV space here. This face there has a UV space there and there. And it's not really going to do much for me to select it and move them around because we can reposition this. But let me turn on the built-in checkerboard pattern that comes with Maya. And we do that by coming up and just clicking this little checker map right here. And we see this checkerboard pattern and we see it displaying on our model. So if we move it around, we can see it moving around on that surface. So what we need to do as 3D modelers is we need to make sure that our objects stay nice in our UV space. And there are different ways to approach UV unwrapping. My personal approach is I do unwrap at the same time as I model, but you might not be comfortable with that method and you might prefer just to model first and then unwrap at the end. So, you know, the more comfortable you get with this, I do recommend that you try to integrate unwrapping as you go, because ultimately it will save you more time. But there's nothing wrong with, when you're new, kind of going through chunk by chunk and going through all these steps. So we have this UV space, and what I would like to discuss right now, and you're going to get really tired of hearing me talk about this topic, is texal density. Texal density is extremely important to understand, and it greatly affects the look of your model. The texal density might also be referred to as pixel ratio or pixel density, but the term that we should try to be more familiar with and use is texal density. And what that is it is how many pixels are on the surface of your model based on its size. So in other words, texel density is the amount of texture resolution on a mesh. So pixels are the smallest unit of information that are on your screen, and then texels are the smallest unit of information that make up a texture. So, this one by default is pretty clean, pretty straight, but I do have a sample scene that I made of a couple objects that have a poor mismatched texel density. So I'm going to unhide it real quick. And I did use this texture. Let me show it to you. Instead of that checkerboard, you might prefer to use a UV checker that looks more like this, because it can be a little bit easier to see what's going on and the orientation of your objects. There's a whole bunch of different styles of UV checkers that you can get, but as long as they are square and a power of 2, that should work fine for you. So I already created a material with that, but let me turn it on and show you what I mean by texel density. There we go. So I have this image, looks like this. I want it to look evenly and as little distortion as possible on all of my objects. We want them to be of the same size on each of them, and that is texel density. So we're going to say that this plane down here is the texel density that we want. So this texel density, it's way too packed. We're getting way too much resolution on that. We'll ignore the fact that it is stretched a little bit, or squished, whichever way you want to think of it. This one has too low of a texel density, so we need to match it to this one. There's a lot of different tools that we can do that, and I'm not going to show it in this video. I just want to talk a little bit about what texel density is. So texel density is usually determined at the start of a project. If you're working in a larger team, your art director or a lead artist will probably give you what your texel density is. Texel density is determined by how many pixels you want to take up a meter by meter space, usually, to make the numbers really nice. So, I made this a 100 centimeter by 100 centimeter plane, which means it is 1 meter by 1 meter. My image is a 1024 by 1024. When you are working with textures, you always want to keep your textures in a power of 2. So that would be, 256, 512, 1024, 2048, 4096. We probably don't need to go up to 8K. 4096 is probably going to be your largest one. So we have an image that is 1024. We have a plane that is 100 centimeters. So we would take that 1024 pixels, divide it by the 100 centimeters to get a texel density of 10.24 pixels per centimeter. So we need to make sure that all of our objects have a texel density of 10.24 pixels per centimeter. So I'll show you where we can see this. Don't worry too much about the tools. If you're unfamiliar with how UVing works, there are other videos that are going to kind of go through how to actually use the UV editor. But we can find the texel density underneath Transform, under the UV toolkit, all the way at the bottom. This texel density, do you see how it says pix per unit? So we're working with pix per centimeter. So if we set it to 10.24, that's the 1024 image, 1024 image divided by the 100 centimeters. So we get a resolution of 10.24 for that map size of 1024. You really can't see it since it is perfect. It might be really hard to see, but we are fitting perfectly on that. So what if we change this? What if we need to work on a map that is larger? Like, what if we decide that, oh no, we actually are going to work on a 2048? We shouldn't just drop a 2048 on here because that is going to change our textile density. If we, keep it at this size and just jump it up to a 2048 image, it's going to make our image sharper, and that's not what we want. We would want to change this to a map size of 2048, and then I'm going to set it. And notice that it shrinks down because we're using a larger map. It only needs to take up then a quarter of that image to maintain that textile density. It's a little bit blurry here because I didn't actually import in a 2048, but this is just to illustrate that if we do want to use a larger map, ultimately, we will have to go in and shrink them down. What if we had a smaller map, like a 512? That is going to have it be larger to maintain the details, those pixels. So if we select, for instance, this wall, sorry, let me get out of here. Too many windows for a demo. I'll select this wall. We can see that one, it is squished. It's kind of weird looking, but the textile density is definitely incorrect. So I'm going to fix this real quick. Don't worry quite how I am fixing this. I'm going to go over this in another video, but let me quickly set this. Let me align it a little bit better. Sorry, hold on. There it is. And we need to match the textile density. So let's actually get it and see what it is, because I can select it and say, let me put this back at the 1024 and reset this to what it needs to be. Oops, I'm sorry. I was selecting the wrong one. It's hard to work with all these little windows sometimes. Let me set this back to 1024. There we go. What is the textile density of this wall? Let's see. I can select that. And I can do a get. And we can see, the textile density is 73.078, which is a lot more dense than this one, and we can't have that. Yeah, it might look crisper, but if one object looks really crisp in the scene and the other ones look a little bit blurrier, we're going to break illusion and it's going to look amateur. So our goal is to make sure that our textile density is consistent on all of our objects in this scene. So let me fix that. I'm going to set this at 10.24. Set. And now they're matching. We would want to make sure we do that for all of these so that they look the same. Notice that I'm not caring too much at this point where this is in UV space. Yeah, we do need to keep it in the square, but for this early week, we're going to just be working with tileable materials like this. So yeah, we should probably pull this up closer, but don't worry about it not fitting in the space. This one obviously will fit in the space because it is perfect to it, but this one is much larger, and that's okay because wherever it goes past it, it's just going to tile again from the bottom because we are working with tileable materials. So again, to iterate, how do we calculate textile density? This is a really important thing. The first thing to know is usually you might be told this if you're working on a larger project. This is going to be determined based on what type of project. If you are doing a first-person shooter and you're character is going to be really close, your texel density is going to be a lot higher because you need those crisper images. If you're doing a game that's kind of pulled back and it's kind of like a top-down strategy game, your texel density is going to be a lot lower. So how do we calculate that? What is our map size? 1024. Ooh, that's a dark color or light color. Let me fix that real quick. 1024 pixels. We're then going to divide that. Oh, there's no good divide on here, just like that. That's good. Divide it by our tileable size. So usually it's going to be 100 centimeters. That will give us our texel density. So in this case, we're going to have a texel density of 10.24 pixels per centimeter. And this is a decent size for working with, for what we're working with. Most likely in these earlier assignments, if we are working with tileable textures, I'm going to tell you what your texel density is. 1024 divided by 100 gives us that. If we need to work with larger maps, but we're still working at that 100 centimeters, and we want it to fit perfectly on that. So not cut in half, like I said, but we want that full 100 centimeters to take up that full 1024 map. We want a crisp resolution. This would give us a texel density of 20.48 pixels per centimeter. So this one will be a little bit blurrier because we're working with a smaller one. This one will be a lot crisper, but we will need a larger map. So UV space, texel density, super important. That's all I really wanted to talk about with this one. I will have other videos that really delve into how to unwrap things.